So now we're going to talk about finding the partial sums of arithmetic sequences. The reason that they have to be partial sums, because if you're looking at a series, which as we know means infinite series, it would mean that we're looking at, for instance, 1 plus 2 plus 3 plus 4 plus 5, all the way out to infinity, which, if you think about it carefully, is never actually going to close. That is, it'll end up equaling infinity every time, which is kind of boring. So, for the partial sum of a arithmetic sequence, the reason we call it partial is because we're just looking at part of that series, because technically when we're adding them, adding the terms in the sequence, it is a series. This means that I'm looking at, in this case, the first 5 terms of a pretty simple arithmetic sequence. In fact, we know that a sub 1 is equal to 1, and d is equal to, you guessed it, 1. The reason I'm doing this is to illustrate the general principle involved, and then we'll talk about a slightly more complicated example. When we start doing some of the homework problems, you'll see what I'm talking about. So what I'm going to do is I'm going to take this sequence, because I want to find out this sum. Now, if you think about it, this is pretty easy to add up by hand. Let's pretend that we can't do that very easily, or the numbers are so horrible, or there's so many terms that we can't really do this. So what I'm going to do is illustrate what happens if I take the same sequence, that is 5 plus 4 plus 3 plus 2 plus 1, reverse it, and then add the whole mess together. Now, if we think about this carefully, this sequence has 5 terms. So I'm adding the first 5 terms together, right? And that means that if I add it to itself, now please note, all these, when you add them, the first to the last, second to first, or the second to second to last, they all end up being the same value, that is 6. So technically, this is the same as saying 5 times 6, which is 30. However, because I've added this sequence to itself, this is twice, that is 5 times 6 is twice what I want. So I have to divide by 2, because I have the first and then the sequence. So the purple plus the blue is going to double what I'm supposed to get, which is in reality 15. Whoopsie. 15. See if we can avoid doing that. There we go. So let's take a look at a slightly more complicated example and generalize what we're talking about. So if I take another sequence like 3 plus, let's go big, 7 plus 11 plus 15, right? Plus 19, let's say, right? First off, I know that there are 5 terms. So there are 5 terms, right? And so I have 5 terms, 5 terms. And I know that the first term, a sub 1, is equal to 3. And I know that the last term, which it must be a sub 5, is equal to 19. Remember, when we're adding these, 1, 2, 3, 4, 5, a sub n, right? But we already knew that. If I were to take the first term plus the last term, that is the first term plus the last term, 3 plus 19, that would be 22. Now, if I reverse this and actually add it all up, 19 plus 15 plus 11 plus 7 plus 3, just like last time, all of these terms are going to add up to, you guessed it, 22. How many terms are there? Why there are 5 of those. However, this is going to overcount by a factor of 2. There may be 5 22s, but I have to divide it in half because it came from adding it to itself, which means that I'm looking at 5 divided by 2 times 22. Now remember, the magic of all this is I could take 22 and divide it by 2, couldn't I? Before I then multiply by 5, just because that's easier. So it turns out the sum is 55. And we could say that the S of 5, right? Yes, could be equal to 55. So let's make this in general terms, and I'll show you a couple different ways that we can do this. In general, to find the sum of the first n terms, that is 1 through n, right, of this first of an arithmetic sequence, is you need to take the number of terms divided, not terms, divided by 2 times the first term plus the last. Another way of writing that is the sum from n equals 1 to, I don't know, let's say I, right, would be, well, from 1 to I is how many terms? Let's say some arithmetic sequence. So let's say a sub 1 plus 2n. That would be equal to what? Well, there's I terms, but divided by 2 times the first term, which would be a sub 1. I'm sorry, it would be a sub n. A sub 1 plus a sub I, because a sub I would be the ith term, that is the last term in this sequence. Okay. Simply put, that's it. Add the first and the last term. Now you may need the explicit formula to figure out the last term. Add those up, and that's what all those terms are going to add up to. But because you're adding it to itself, you have to divide by 2 times the number of terms you're adding. Once we start doing some more examples, you'll see exactly what I'm talking about. It's not too terrible.